previous part, we talked about the introduction, the types of motion, and we said we will be talking about the oscillatory motion. So we'll talk about the definition, and we'll take what are the types of oscillatory motion. So first, what do you mean by oscillation? Examples. So we have here the pendulum, it's making an oscillatory motion. Then here also we have an oscillatory motion, and in the third case, these are three figures where we have oscillatory motion. So what do we notice? We notice that an oscillatory motion is a back and forth motion. Okay, but it's not only back and forth motion, where we have a position of equilibrium. So let's take the other figure here. So here, for example, I have, this was the pendulum at equilibrium, the horizontal elastic pendulum at equilibrium. Then when I compress it or I elongate it, then what will happen? It will go to a maximum and then it will come back. So we'll have a back and forth motion. Okay, so it will reach here and then come back. This back and forth motion about the position of equilibrium, which is here, and reaching two extremities, this is the first extremity and this is the second extremity, then this type of motion is called the oscillatory motion. Now, what do we have as types? We have the free oscillation, we have the driven oscillation, and we have the forced oscillation. So in the free oscillation, we'll talk also about undamped and damped oscillation. So, and we'll take two cases or even many cases. From these cases, we have the horizontal elastic pendulum and the vertical elastic pendulum. So what do you mean by first free oscillation? In the free oscillation, it's, for example, here, when I, for example, elongate the spring and then I release it. So when I release the spring, my hand, so I just keep it by going back and forth without any force outside. And this is what we call a free oscillation. Now, in the free oscillation, we have two parts. We said we have two parts. We have the free undamped oscillation and the free damped oscillation. When I say undamped oscillation, this means there's no loss of energy. And this is when I say that there's no friction. بهذا الكيس بنلاحظ that the spring will do oscillatory motion and the maximum and the minimum won't change. يعني حتضل تروح وتجي to infinity. And this is what we call so the amplitude won't decrease. There's no loss of energy. And this is what we call the free undamped oscillation. As in the case of a free damped oscillation, so it's also free. This means I just elongate it and then release it. There's no other forces. But when I say damped, then this means we have friction. So, and when we have friction, we'll notice that the energy will decrease with time. We'll have loss of energy. And when we have loss of energy, then at a certain instant, this oscillation will stop. يعني هتبلش, for example, here توصل مثلا لهون, and when I release it, okay, if I release it, so هتوصل, for example, لهون, and then here it will be the maximum amplitude, ومع الوقت راح ترجع تصغر لتوصل at the end and it will stop. This is what you call the free damped oscillation, and this is due to the existence of a frictional force. Now, what do you mean by, what are the, if you want to say the different cases in the free damped oscillation? So the cases differ according to the friction. If the friction is small, so we have light damping. So بنلاحظ إنه الامplitude بتصغر بس بتصغر شوي with time. And if we have heavy damping, then the friction will be higher. So if this is F1 here, and here we have F2, then here the friction is greater. Then we have the critical damping and the over damping. In these two cases, the friction is very larger. So we notice even ما حتقدر تعمل one oscillation حتى, and then it will come to zero. So رح توقف, يعني even ما حتقدر تعمل one oscillation. So these are the cases where we have friction of free damped oscillation.